Hello everyone, in today's session we shall discuss about couple and principle of moments. In my previous video, I have told you about the moment of force. In our daily life also we come across this moment of force where we will have turning effect on the bodies. We have lot of applications of moment of force in our everyday life. One such example is, if you want to tighten a nut, then you have to use a spanner, and we have observed that the spanner will have a very long handle and the force is applied at one end of the spanner. So, as this perpendicular distance increases, then the turning effect on the nut will also be more. This is one example of moment of force, which is nothing but turning effect on the body. Now, here we are discussing only about turning effect. The body will have a turning effect. But if you want to have larger turning effect, if you want to have a larger turning effect, or if you want to rotate the body, then in this case, one force is not enough. You have to apply two forces, and these two forces must be equal in magnitude and they must act parallelly on the same body, and these two forces must be acting at two different points on the body. Suppose if the body has to be rotated fully, then you have to apply two forces. One force should act here and another force should be acting here, so that the body continues to rotate. Now, in order to have complete rotation of the body, how many forces are required? Two forces are required. And how these two forces should be? These two forces must be equal in the sense equal in magnitude, then they must be parallel, they must be acting in opposite direction, and they must act at two different points on the same body. Now, if these two forces, which are equal in magnitude, if they are parallel, they act in opposite direction at two different points on the same body, then it constitutes a couple. So, if you want to completely rotate the body, then how many forces you require? You require two forces, and these two forces form a couple. So, whenever a couple acts on a body, the body will rotate. So, a couple will tend to rotate the body, or actually rotates the body. In our daily life, we come across couple. Suppose you want to open or close the lid of a bottle. If you want to open or close the lid of a bottle, then how many forces you have to apply? You have to apply two forces. One force away from the bottle, lid of the bottle, and another force towards us. Then these two forces which are acting on the lid will constitute couple, and then the lid starts rotating. Either you can open the lid or close the lid by applying two forces. So this is an example of couple. Apart from this example, we also come across other examples like whenever you want to turn on or turn off the tap, then also you have to apply two forces, and these two forces will be acting on the same body, but they will be acting at two different points. And how they will be? They will be equal in magnitude, and hence these two forces will form a couple. Now, if you take a body, I will consider a rigid bar which is supported at O. Now, if I want to rotate this bar, then I have to apply two forces. One force I should apply in this direction, and another force I should apply in the opposite direction. Now, these two forces must be equal. The magnitude of these two forces should be equal. Whenever this happens, then this rigid bar will rotate about this fixed point O. Now, these two forces, the perpendicular distance between these two forces is called the arm of the couple. And if you know the magnitude of these two forces, then you can calculate the moment of couple. Moment of couple is given by force into arm of the couple. So, this is one more formula you have to remember. Here we are calculating the moment of force at both the points. Suppose if A and B are the two ends of this rigid bar, then we have to calculate the moment of force at A and moment of force at B. And if you add the moment of force at A and B, then it will be equal to force into arm of the couple. That can be verified here. Moment of force at A, it will be equal to F into OA. Moment of force at B will be equal to F into OB. Now, if you want to calculate the moment of couple will be equal to F into OA plus OB. OA plus OB will be equal to AB. So, F into AB. So, force multiplied by arm of the couple. In this diagram, the arm of the couple is represented by AB. So, remember, moment of couple is equal to force into arm of the couple. And you can even write the units for this. And the units will be same as that of moment of force. So, the units will be Newton meter. So, this is about couple. Now, see this problem. Two forces, each of magnitude 10 Newton, act vertically upwards and downwards respectively at the two ends A and B of a uniform rod of length 4 meter, which is pivoted at its midpoint O as shown in the figure. Now, in this figure, we have a rigid bar, uniform rod of length 4 meters, and it is supported at its midpoint. So, when it is supported at midpoint, here OA will be equal to 2 meter. And OB will be equal to 2 meter. Now, what you have to calculate? You have to determine the magnitude of resultant moment of forces about the point O. So, at the point O, what will be the resultant moment? Now, you just observe in the figure, these two forces are acting in opposite direction and their magnitudes are also same. Now, if you take the moment of force formula, then moment of force at A will be equal to force into OA, that is equal to 10 Newton multiplied by 2 meter. This will be equal to 20 Newton meter. Now, likewise, moment of force at B will be equal to F into OB. This will be equal to again 10 Newton into 2 meter. This will be 20 Newton meter. Now, if you want to calculate the resultant moment, see, this will produce clockwise moment. This force also will produce clockwise moment. So, the resultant moment will be in clockwise direction only. If you calculate the moment of force at A, this is 20 Newton meter clockwise. Moment of force at B, this is also 20 Newton meter clockwise. These two forces are acting in opposite directions. So the resultant of these two forces will be in clockwise direction only. This will be equal to 20 Newton meter plus 20 Newton meter, that is equal to 40 Newton meter clockwise. This is the resultant moment of forces about the point O. Now here, if this rigid bar starts rotating, then you can calculate the moment of couple also. Here moment of couple can be calculated by using the formula force into arm of the couple. Now here the forces are identical, so you can take the force as 10 Newton. Now what is the arm of the couple? Arm of the couple is a 4 meter. This will be equal to 40 Newton meter. The moment of couple also will be equal to 40 Newton meter. So this is the solution for this problem. Either you can calculate the moment of force separately, or you can directly go for moment of couple. Whenever couple acts, then this uniform rod starts rotating about the point O. Now we shall state the principle of moments and try to solve one problem on principle of moments. Now before we go for principle of moments, you must remember that whenever forces are acting on a body, the body can continue to be at rest, or the body can continue to be in a state of motion. That state is called equilibrium. So even though forces are acting on the body can remain at rest, or the body can be in motion. Then the body is said to be in equilibrium. And there are two types of equilibrium. One is a static equilibrium and the other is a dynamic equilibrium. Now in static equilibrium, even though forces are acting on the body continues to be at rest. In case of dynamic equilibrium, even though forces are acting on the body continues to be in motion. So in our daily life, we come across many examples of static and dynamic equilibrium. Now, whenever a body is in equilibrium, then you must remember that clockwise moments will be equal to anti-clockwise moment. Now let us take this example. This is a rigid bar which is supported at the midpoint O. Now here one force is acting and here another force is acting. Now this force will produce clockwise moment and this force will produce anti-clockwise moment. If this rigid bar has to be in equilibrium condition, then what should be the condition? The clockwise moment must be equal to anti-clockwise moment. So the principle of moment states that according to principle of moments, anti-clockwise moment is equal to clockwise moments. Or you can even state it as, if the algebraic sum of all the moments of forces is 0, then the body is said to be in equilibrium. So this is the principle of moments. So always remember, whenever a body has to be in equilibrium condition, then a number of forces will be acting on the body, but the resultant of all the forces will be equal to 0, and the algebraic sum of all the forces acting on the body will be equal to 0. In such cases, the body will be in equilibrium condition, and this is what the principle of moments say. So anti-clockwise moments will be always equal to clockwise moments. If you have this, then the body will be in equilibrium condition. Now let us take one problem on principle of moments. Okay, we have a problem on principle of moments. A uniform meter rule is pivoted at its midpoint. A weight of 50 gram force is suspended at one end of it. Where should a weight of 100 gram force be suspended to keep the rule horizontal? Now, before you proceed with the problem, better draw schematic diagram of the problem given. So, what he is telling, a uniform meter rule. Uniform meter rule, usually it will be 100 centimeter, and it is pivoted at its midpoint. So, at its midpoint it is supported. Uniform meter rule will be 1 meter rule or 100 centimeter rule. If it is pivoted at its midpoint, then this will be 50 centimeter and this side will be 50 centimeter. Now, what is given? A weight of 50 gram force is suspended at one end of it. So, any one end, I will consider this end. At this end, a weight is suspended, and this is equal to 50 gram force. Now, this will be equal to 0 if you consider from this end. Where should a weight of 100 gram force be suspended to keep the rule horizontal? Now, if a weight of 50 gram force is suspended at this point, then the rule will not be in horizontal position. If you want to bring it in horizontal position, or if you want to make it in equilibrium condition, then one more force or weight should be hung at this side. How much force or how much weight is hung here? It is 100 gram force. You have to calculate at what distance this weight has to be hung. This is the problem. Now this problem can be solved by principle of moments only. Now let us calculate what is the moment of force at here at this point. So it will be equal to 50 multiplied by, now from the fulcrum or pivot, what is the distance at which this weight is hung? It is 50 centimeter. So this will be equal to 2500 gram force centimeter. This is 50 gram force multiplied by 50 centimeter, which will be equal to 2500 gram force centimeter, and this will have anti-clockwise moment. Now this side if you take, it is again 100 gram force multiplied by, we don't know this distance at what it should be hung. Yes, this will be equal to 100 gram force centimeter, and it is clockwise. So this is anti-clockwise and this is clockwise. Now, by principle of moments, what we have learned? Anti-clockwise moment must be equal to clockwise moment. So what is the anti-clockwise moment we have calculated? 2500 gram force centimeter. This will be equal to 100 gram force centimeter. 100 into x, if I am correct. 100 into x. So this will be 100 into x. Now x will be equal to 2500 by 100. So it comes to 25 centimeter. So if you want to bring this uniform meter rule into equilibrium condition or make it horizontal, then you have to hang this weight of 100 gram force. At what distance? You have to hang it at a distance of 25 centimeter from the other end. So this is 0, this is 100. From this end, at a distance of 25 centimeter, you have to hang this weight. Then the rule will be in horizontal position. Therefore, x will be equal to 25 centimeter.